So we're going to take a look at using an identity matrix. So first let's talk about what in the world would an identity matrix be? What is it? And let's connect it to something that we already know. So if I come over here and say, hey, what is the thing that I add to 5 to get a 5 again? Well, you would obviously put a 0. Well, this is called the additive identity. Well, it makes sense, right? It's the thing that I add to something that gives me the same identity that I started with. Well, if I said, what is the thing that I would multiply times 5 to get a 5, you would say it's the 1. And that's because we're talking about multiplication. It's the multiplicative identity. Well, in matrix work, right, we have the same thing. When we're talking about multiplication, we have an identity matrix. Well, we actually call it the identity matrix, and we give it the capital letter I. So whenever you're asked about the identity matrix, just think, hey, 5 times 1 is 5. It's the thing that will give you the same identity that you started with, right? Pardon the bad grammar. So let's take a look at what the identity matrix is. We're going to have a 1 right here and a 0 right here. You're going to see why in just a bit. And we're going to have a 0 at the front of the second row and a 1 on the last one. Now, again, if this is a 2 by 2. If it were a 3 by 3, we would have diagonals right across the 3 rows and columns. So let's take a look. They want us to show that IB is equal to B. Whoops. Let me move that to the other side, because when they give us some directions to multiply using matrices, we don't have a right to move it around, right? So I'm going to do this one. Whoa. I'm going to do this one first. I guess I should get a black. Okay, I'm going to do this one first. So that's this right here. So there's my identity matrix times my matrix B. So let's take a look. I'm going to say that times that. By the way, my answer will be a 2 by 2, and I always make it a little bit larger, right? Because I'm going to do the work in the matrix itself. And then go ahead and finish up here. I have 1 by 3 plus 0 by times 2, and that's going to give me a 3. A 3. Pardon me. I'm going to do this row times this column now. Always finish all the columns using the top row. Get everything done you can with the top row. So I have 1 by 4 plus a 0 by negative 1, so that's a 4. Now down here, and we're going to go here, so that's 0 times 3 plus 1 times 2, and that's going to give me a 2. And then I have this times the last column, 0 times 4 plus 1 times negative 1, and that's going to give me a 0. Whoa, that's going to give me a negative 1. It's a 0 plus a negative 1. That's a negative 1. All right, so if you can see that we ended up with the same thing with which we started. Okay, so the identity matrix is this red one. The identity matrix is that red one. So let's see. We're going to then multiply B times I. So let's go ahead and do that. 3, 2, and if you think about it, we can do this because they're square matrices, right? Okay. So we'll now do it multiplying B times I. So let's see what we get there. That times that. So this time I'm just going to go right to the answer. 3 times 1 plus nothing is 3. Now you can see why this is working, right? This 0 is going to create nothing from the 3, but the 1 times the 4 is going to give me the identity 4. Alright, so that times this one gives me a 2, but nothing from the second term, and then this times this is going to give me nothing from the first term, but negative 1 for the second one. So both of them work. Here's my original, there's the identity, here's my same answer. So that's it. That's using an identity matrix. Hope this was helpful. Thanks a lot.